We're looking here at question paper 4.2. Okay, question number 9 now, and this is winter 21, of course. All right, we're going to look at a kind of confusing situation where we've got a helium balloon attached to a spring, obviously. Spring is attached to tabletop, and the balloon is in equilibrium. Equilibrium, I've kind of circled that, and I'm sure I meant to write something interesting there, is the state of zero force. In other words, we're not accelerating. Okay, it's also the state of zero moment, which means we're not rotating, or we're not accelerating in a rotating way, but we won't worry about that too much right now. We are told that the helium balloon has a mass of 6.5 grams. Okay, now, key point there, grams. If you're ever seeing grams, my suggestion is to convert into kilograms. All you have to do is divide by 1,000, okay, to get that value in kilograms. We're asked to calculate the weight, and we're told the gravitational field strength. Now, weight is made by gravity, W equal to mg, okay, and therefore we've got 0.0065 kilograms times 10, 0.065 newtons. Okay, now you notice there, all right, in the answer, they're kind of expecting you already to pick up the fact that those units are kind of different. There's no extra marks available for that, which is kind of a surprise for GCSE, especially 0654. However, we work within what the rules of the game that we're playing in, so that's what we're going for. Okay, we're then asked about the balloon causing the spring to extend. If you ever see a spring in a physics question, you know that you're going to use this equation, F equal to kx. Forces cause extension. Okay, I'm well aware that cause does not begin with a K. That's the best one I could do. All right, forces, yeah, we'll work out something else later. This F is the force, K obviously is spring constant, and E or X for extension, that is going to be the change in the length. So let's have a look. We're causing the spring to extend by 0.50 centimeters. The spring constant is 0.45 newtons per centimeter. And so what we're going to do is put those values in and multiply them. Now, notice here, we do not need to change any units. Even though we usually deal with meters, well, everything's in centimeters here. So as long as everything else is in centimeters, we can take a little shortcut and we can find out. You could obviously change into meters, but that will be a conversion that would cause some students some problems, and that will then probably end up losing marks. So if you see centimeters twice, you're probably pretty safe just to put the numbers in. Okay, so we've got force 0.225 newtons. Okay, now, what we want to now think about is talk about this total downwards force. We're thinking about the adding together of forces. Let's think about these two forces. The weight is down. Weight's always down, okay, towards the center of the Earth. But what's the direction of this F that we've just calculated? Well, think about it. The balloon is trying to go up, and without that spring attached to it, it would go up. So that force from the spring must be pulling down. So we actually have a total force there of the sum of the two, 0.065 plus 0.225, 0.29 newtons. And what that really means is that the total upward force is 0.29 newtons because it's balancing the downward force wherever I am. We'll go over here, okay? So we've got down 0.29 and up also 0.29. We then take a kind of left turn, okay, to talk a little bit about temperature, all right? In these questions, we often combine multiple different bits of physics. That's one of the features of this syllabus. The student places the balloon under an infrared lamp, okay? Suggest the color balloon which would give the greatest rate of increase. Now, what this really means is which will take in the most energy. Now, the one that will take in the most energy, okay, is black. You should be aware of this. Whenever it's a hot day, sunny day, the road, for example, gets very, very hot, and that's because the road is usually black in most countries. Okay, it's made of tarmac, which is a black substance. That's absorbing a lot of sun's energy, which is then getting very, very hot. And so therefore, it's going to get a very high rate of increase in gas temperature. And that's what we want to do. If we want my balloon to heat up quickly, I should colour it black. If I don't want it to heat up quickly, I colour it white, colour it silver, something like that, which will reflect the energy and therefore heat up less quickly. Okay, so we've got the colour is black, and we've got the black surfaces absorb more infrared radiation, and therefore it will heat up more quickly. Okay, so 1 mark really there for the colour and another mark for the explanation. Then we're asked to explain what happens to the size of the balloon. Okay, lovely question. 3 marker as well, so we want 3 statements. Now let's think about this. Let's try and think of it step by step. First things first, temperature goes up. Temperature goes up, well, therefore molecules become more active. Okay, What's that mean for inside the balloon? We've got more activity, more collisions with the walls, specifically the walls, not the particles. More collisions with the walls, and therefore a greater force inside. So we've gone from A, greater temperature, to B, greater force, and therefore greater pressure. Now that pressure is going to cause the volume to increase. All right, now notice in my answer, I've kind of tried to tell that story. Temperature increases, molecules faster, more collisions, greater force, greater pressure, and therefore leading to volume increase. Now, if we look at the mark scheme, okay, you're looking at these kind of explanation points, all right? The answer already tells you what happens to the balloon, okay? What you need to do is explain it. So you're going to have 3 marks for explaining, okay? More often, with the collisions more often, okay, larger force and therefore higher pressure. So we're wanting all of these 3 points, okay? Beginning, middle, and end. Now this is the kind of question I'd normally notice students get a couple of marks on. When you're rereading these, have a think. Generally the rule, 3 marks, 3 sentences, or 3 marks, 3 points would be a good kind of way of judging your quality of your answer, okay? But I'm sure that as you've done a couple of these papers, you'll notice these questions do get repeated, and the more you do, you'll notice the more helpful that repetition becomes. Okay, I'm going to stop there. Usual story, subscribe if you'd like more videos, ask me if you want a particular one, I'm more than happy to help, and above anything, enjoy doing your physics revision. It may be the last time for some of you guys. I'm sure you're going to do really well. Let's go out with a bit of a bang, all right? Thanks, folks.